Hello and welcome to this tutorial sessions where we discuss eventually the Coriolis force, but in this session we will try to understand how the polar coordinates are represented and how we convert a Cartesian into a polar one. Now when we say Cartesian, we have x-axis and the y-axis, and they have a reference vector, a unit vector. Along x-axis is I cap and along the y-axis is j cap. So any point we reference over here would be, let's say if this is a r vector, then this r vector we can write as x I cap plus y j cap. In polar system we reference any point with the help of two parameters r and theta, where r is a distance from the origin and theta is the elevation of that vector. Now the once we say, now if we combine, let's say the Cartesian and the polar, let's try to superimpose and try to see both of them in a same diagram. This is the x-axis, this is x-axis, this is y-axis. So clearly we have a point, let's say this point is P in question. Now we can see that this is a radially outward direction, this is radially outward direction r cap, and we have perpendicular to that is theta cap, which is, so we again have two references, r cap and theta cap for the polar coordinates. These are the reference vectors. For the Cartesian we have I cap and j cap. So clearly if we can see over here, the r r cap component, the r cap unit vector can be written in terms of say Cartesian by taking the components along the x and the y, which is cos theta and sin theta respectively. Also theta cap direction can also be represented in terms of a Cartesian coordinate by taking their respective, for example this angle is theta, so we can see that it is going to have a component in the minus x direction and the positive y directions, and the components are respectively minus sin theta and cos theta. So remember these two, okay? It's a conversion. Also what we are writing when we say theta dot, this means d theta by dt, which is time derivative of the angle. And when we say theta double dot, this means the second derivative of angle with respect to time. Clearly the angle is also changing with respect to time, so we are taking a second derivative of the angle with respect to time. Now clearly let's come back to the representation part. So clearly what do we have? Now these two equations r and theta, when we differentiate we get something like this, right? And remember this equation, this will be handy when we write the final expression for the velocity. Similarly if we differentiate we get this. Let's see the first one. So r is this, r is this. So if we differentiate, differential of cos becomes minus sine and differential of sine becomes cos, because we are differentiating with respect to time t. So using a chain rule we have theta dot and theta dot over here. If we take this common we get theta dot outside, and whatever is left behind you can see it is this expression. So we have this one. Similarly you can test it for the second expression also. Now coming back to our main point, so any vector r we can write, for example in this we can write this as r into this is basically the modulus of the vector, r is modulus of the vector and r cap is a direction. Now if we differentiate this, so we are trying to evaluate the vector for velocity. So what do we have? Now clearly when we write over here and we put all those terms, for example in place of dr by dt we put a term from here, in place of r cap let it be like that only, and in place of let's say dr by dt, for this dr by dt we have the expression over here, right? This is dr by dt, and if we put certain things over here, so what do we get? So this is a velocity vector. So let's write down the final expression that we have, for this. This is velocity vector. This would be equal to, when we say dr by dt, now putting this value, so we get this would be r dot into r cap, right? The second term we have r, and differential of the unit vector along the radius direction, right, we get dr by d theta. This is nothing but if we put the value from here, this will be equal to r theta dot theta cap, right? So basically it would mean that the velocity have two components. One is radially outward and second is perpendicular to the radially outward directions. So basically if you have a point which is moving in a circle, right, so we have one component along r cap and the second component along theta cap. So this is the expression that you have to understand. This is the basis with which we'll derive the Coriolis expression for acceleration, right? Thanks for watching this video. Do continue watching this for the second half. Thanks.